Welcome to Electric Evolution with Liz Allen. This podcast is about the journey to a more sustainable future in order for us to be able to do our bit to achieve net zero. I'll be discussing a variety of topics with experts in their field in order to educate and increase our knowledge of clean energy, electric vehicles and the electric vehicle infrastructure. So whether you're an individual wanting to make a difference at home, a small business or a corporate, this podcast is just for you. Today on the podcast, I have got with me Dr. Ewan McTurk, who is, and I'm going to quote all this because you are a consultant battery electrochemist at Plug Life Consulting Limited, creator and presenter of Plug Life Television, which is a YouTube channel. You worked as an electrochemist at, is it Dacosi? Dacosi?
Yeah, Dacosi.
A cell-based battery manufacturer in Scotland. You've got a PhD from the University of St Andrews. Is it an MSci? What did you call it? MSci from the University of Dundee. And you carried on studying lithium-ion cell chemistry. That is one CV to start off with. And that's only me reading up on you and kind of going, oh my God, this guy. So how did you actually get into this field of study? What was it about it that got you interested, and what are you doing now?
So I didn't choose the Plug Life. The Plug Life chose me. So when I was at the University of Dundee and I was going into my honours year and I was trying to decide what I wanted to do for my project, this 1999 Peugeot 106 Electric turned up, parked outside the physics building. It had just been acquired by the university. And I thought, wow, that's pretty awesome. I hadn't really thought about electric cars before. This would have been 2009. So, the iNEV had possibly just been released. The Leaf hadn't been released yet. The Tesla Roadster was barely a thing at the time. And here was an opportunity to potentially get behind the wheel of one and under the bonnet and see how they work and how we can improve them. And so I ended up doing a project on next generation battery chemistries and some work with that electric vehicle too, which I ended up buying that EV and taking it with me. It was the first EV I ever drove, and it was the one that inspired me to go down the battery route, and it launched my career as I know it today. So it was that chance encounter with that car that resulted in where I am now.
That is amazing. And you said to me that it's actually in a transport museum at the moment, didn't you?
Yeah, it's on display in Dundee Museum of Transport, although annoyingly they're about to change their exhibit. So it's looking for a new roof over its head. Any museums out there?
Yeah, anybody who knows people in transport museums that want to take. So it's a Peugeot. Remind me, what is it?
Yeah, Peugeot 106 Electric, factory built by Peugeot with NiCad batteries. It just looks like a normal Peugeot on the outside, but very different under the bonnet, and very punchy, torquey little machine. Great to drive. Has tartan seats as well.
Oh, perfect. Mm-hmm. Oh my goodness. So yes, anybody who can help Ewan out with this one, then please, I will share your details later when we'll get to that bit in a little while. So I'll share everything. Super. So that they can contact you if anybody knows anybody, or anybody's in the know, should I say. So this is a question that I've been wondering about for ages. Can you explain, so how is a lithium battery manufactured for an electric vehicle? How does it actually work? Where are they normally manufactured, and how are they manufactured, and how are they what's the process for it?
So, you'll typically have very large-scale gigafactories in which you'll produce the individual lithium-ion cells. The economies of scale mean that the bigger the factory, obviously the lower the costs are overall. So what you'll do is you'll have your two different electrode slurries. You'll have your positive and your negative electrode. So that's the cathode and the anode. And when you're mixing the anode, it's generally carbon with a little bit of silicon in there, or graphite, I should say, with a little bit of silicon in there. And then for the cathode, the positive electrode, it will be some sort of lithium metal oxide. So the original lithium-ion cell was LCO, lithium cobalt oxide. So that was about 39% cobalt. But we've seen that cobalt content replaced with nickel and with manganese, so NMC. And you'll normally have a number after the NMC that tells you the ratio. So we've gone from LCO to NMC 811 in leading electric vehicle batteries. 8 parts nickel, 1 part manganese, 1 part cobalt. So that's a 90% reduction in the amount of cobalt in an EV battery in just over a decade, really. So what you'll have there is your lithium metal oxide for the positive and your kind of graphite silicon for the negative. Those will be mixed in separate slurries, which are then coated onto a copper foil for the negative electrode and an aluminium foil for the positive electrode. And that's done with like micron precision to get a really thin but consistent layer. But of course, that slurry is wet. It's probably got a binder called NMP, which is not a particularly pleasant solvent. It's somewhat dangerous. So you want to make sure that you recover that and recycle it, use it in further slurries. So you dry it off in a series of high temperature ovens. And so you've got this kind of reel-to-reel process of this reel of metal foil with the current collector, foil, I should say, with the slurry coated on top of it. It's just going through these different temperature stages, which have been optimized during manufacturing for the best performance of the cell later on. So then you end up with a reel of dried coated on, baked on electrode material. And then depending on whether you're making pouch cells, so similar to what you have in a mobile phone, it's basically a laminated aluminium pouch, kind of baggy thing, the pouches can be any size you want them to be, really, but in most electric vehicles, depending on the style, it's probably about the size of a sheet of A4 paper, or maybe kind of a thinner version of it. Yeah. But basically with a bunch of stacks of electrodes in them. And to get those stacks of electrodes, you basically stamp them out of the roll. Yeah. The other thing that you can do with a cylindrical, so just like you have in a Tesla Model S, in fact, here's one that Elon made earlier. Yeah, there we go. That's basically out of a Model S. So what you would do, because what's inside here is a so-called jelly roll. So what you do is you have 2 big long strips, one positive, one negative electrode, and then you just kind of wind them together with a separator, kind of plasticky material that doesn't let electrons through but does let lithium ions through. So it's ionically conductive, electrically insulating, and that means that the ions can move between the 2 electrodes and complete the reaction, but the electrons have to go through the external circuit. So they have to go out one terminal, around, power your car, and then in the other. And that's because obviously if they could complete the journey, the electrons inside the cell, that would be an internal short circuit, and the thing would very quickly heat up and meet a nasty end. Anyway, point is that you either cut big long slits or stamp out stacks, and then either kind of do a kind of stacking procedure like this with separator winding between them for pouch cells, or the much faster thing to do is cylindrical cells, where you wind them into a jelly roll and then stuff them into a tube.
So the one that you've just shown me, you said that's from an S, from a Tesla.
Tesla
Model S. So what would that power then?
So this particular one is an 18650, and an interesting point to make here is the reason it's called an 18650 is because it's 18 mil diameter and it's 65.0 mil tall. Nobody knows where the extra 0 came from, but anyway, it kind of stuck. So these were originally found in laptop batteries, and the power of these is not spectacular. So you need to put a lot of them in parallel. So in other words, positive to positive, negative to negative, and you're increasing the capacity. So if you were to even attempt to power a Tesla Model S off of one of these for a start, you wouldn't be able to, because the maximum voltage of that cell is about 100th of the system voltage. So you need to have them in series as well. So you're basically building a staircase almost, positive to negative, positive to negative, positive to negative, to get the system voltage that you need, to get that kind of height difference, if you wish. But you need the staircase to be wide enough as well, which is where parallel comes in. So that's why there's thousands of these in a Tesla Model S. So that's where you get your traction power from, is a lot of these stacked in series and in parallel.
Wow. Okay. And you were talking about gigafactories. Now, there's been quite a lot in the news lately about the gigafactory. It's in the north. Is it in the northwest or northeast?
Britishvolt, Blythe, Northumberland.
That was it. What are your thoughts on what's going on there? Because I know they've received funding, haven't they? But then they've not. Am I right? They've not been allowed to use the funding yet.
they have and they haven't. It's like they've been promised some funding from the government, and the government's then kind of gone, well, actually, which is incredibly frustrating, because if you look at what's happening across the pond, the administration in the US right now has absolutely knocked it out the park with the Inflation Reduction Act, because that has given very generous subsidies to people who want to make cells, batteries, electric vehicles, do the recycling of it, create a circular economy. And they've already resulted in companies uprooting entire production lines and factories and moving them across to the States, including Britain's very own Arrival, the electric van company. They were meant to be building a factory here. They're now building it in the States. And Tesla, at the new Berlin Gigafactory, they were going to be building the 4680 production line. So it would be 46 mil wide and 80 mil tall. About the size of a small Coke can that you get in like like the fridge in a hotel room. So they are a completely different design internally to what you would find in an 18650 for reasons that we can go into later if you like. But they're going to be difficult to get right. So the Berlin Gigafactory had been kind of struggling away with this. But then the Inflation Reduction Act was announced, and Tesla went, so we get pretty much paid to develop this over in Texas. Okay, we're just moving the entire production line. So basically the moral of the story here is that has already resulted in that, those businesses aren't just going to disappear. They are building huge assets. We hadn't started to build this one at Britishvolt in Blythe yet. So what we need is for the UK government to respond in kind with generous incentives and actually get behind the industry, because it's not just the cell gigafactory that you're producing, it's the entire automotive supply chain, because automotive manufacturers want to be able to get a local supply of batteries for electric vehicles that they were going to build in the UK. So there will be a huge market for this. Obviously, the UK knows how to build cars and vans and so on. And if we want to modernise that industry and, keep that industry, let alone grow it, we need those incentives. So unfortunately, it's not so much technical, it's 100% political what's happening in Northumberland right now. And it would be a massive missed opportunity, unbelievably sinful for a government to let that go. But yeah, the US has played a blinder, and we need to respond in kind.
Like with like, haven't we? So what do you think it's the move? I mean, I don't want to get into kind of political talk particularly, but do you think it is the move from, kind of prime minister to new prime minister that's kind of...
Yeah.
Is it because
who's in the chair? Who's won the musical chairs this month? Yeah.
Yeah, who's got the lettuce?
Stability.
Was it the lettuce?
Yes, exactly. Yeah, I wonder how that lettuce is getting on.
I know.
Actually,
maybe in this weather.
Yeah, exactly. Yeah, it's probably. Yeah,
right,
I bet you it's still going. Actually, if it's outside, it'll be grand. It's basically a vegetable crisper. But thing is, I think having stability would be incredibly useful, because my understanding is that one minister who's involved, like the business secretary, basically comes in, sits down, the seat's not even warm yet, and they've just had a bunch of civil servants and industry experts explaining to them, so this is Britishvolt, this is the Blythe Gigafactory, this is why it's a good thing for various different reasons. And they go, that sounds great. Okay, so we've got a new Prime Minister and I've just been made redundant.
That
so,
again.
okay, bye. And then someone else comes in. It's like, hello, who are you?
Yeah.
And it's just
musical
this...
chairs, isn't it?
So they, yeah. So all of the industry experts, like the really knowledgeable people within academia and industry who genuinely get this, who know it inside out, are having to go, okay, hello, and start from scratch. And that has cost us time dearly.
Yeah.
But I mean, that said,
go on.
I mean, that said, there are some good news stories, despite it all, not because of it all, despite it all. So if you look, there is actually another cell manufacturer in the UK. It's called Amti Power, and it's based up in Thurso. And they are developing some very interesting niche chemistries that could become pretty mainstream, including one of the first sodium-ion cells in the world. So, they are currently... They've just announced that they're going to be building not a gigafactory, but a mega factory in Dundee at the site of the old Michelin tyre factory, which has been turned into a massive e-mobility hub. So, very successfully so. There's already a battery pack manufacturer there. This would present them with a cell manufacturer. Very exciting times. And what they're doing is they're kind of growing slow but steady. So they've proven themselves on the Thurso production line, which is a small but very important facility. They're building one in Dundee, which will be much bigger and will allow them to produce cells at a higher scale. And then they can say to investors, look, we have very high quality, highly reproducible, cells that shows that we can scale to a gigafactory now. So that's how they've gone at it. Whereas British Volt's gone gigafactory straight away. And that really needs the likes of the Inflation Reduction Act and the UK government to get right behind it and say, yes, we need to go big and we need to go hard. But AMTI Power has thankfully kind of taken the kind of cautious, slowly approach in that sense, and they've come up with some very clever chemistries, and it would be nice if they could grow faster, and any investment they get will allow them to do that. But the way they're going about that means that even if we've got musical chair prime ministers and so on, they can hopefully weather that storm.
So this is you're saying it's a sodium it's a sodium based or sodium ion battery, is that right?
Correct, yeah, one of the many chemistries they're doing. But yeah, the sodium's
have you actually managed to get to see it then? Have you been up there? Well, you're already up there, aren't you, really?
Well, I mean, in fairness, in comparison to Edinburgh, Thurso is a long way away again. It takes longer to get to Thurso than it does to get to London by public transport or driving. But Thurso is basically... Thurso is the very, very north of Scotland, like next stop Orkney.
Oh my God! Okay,
it's like mainland Scotland, I should say.
That's me being a bit dense.
No worries at all.
Oh my God, she's done what? She said what? She's not got to map out again.
But no, genuinely, I've been to the AMTI factory in Thurso, and it's a small facility, but it's one that's endured various different kind of guises. It had a bit of a military background and is now kind of repurposed for civilian application. And I mean, it's incredible because obviously the Thurso is a very, very long way away. There are some very talented engineers from all across the world who work there, but they've also managed to recruit the local workforce. So I believe that. Yeah, I can't remember all of the jobs or previous jobs of some of the people who work there, but one of their team was in a past life a baker. And if you think about it, a baker has to batch cook things with a precise amount of ingredients. And here they are mixing big slurries, big vats of slurries for electrode material for lithium and sodium ion batteries. So transferable skills. And it's great. And as I say, what an environment to be in. Proper fresh air, beautiful landscapes and stuff. Yeah, it's such an interesting place, But anyway, so I've been to the Thurso factory there. Small but very effective. What they're about to build will be substantially bigger.
So, and you said that it's highly reproducible. So compared to regular battery, lithium batteries. Lithium. I call it. I'm pronouncing it wrong as well, aren't I?
Oh, lithium.
Yeah, sorry. Yeah. How are they both similarly reproducible, or kind of is this one because it's kind of manufactured in a different way, or the chemistry is different?
So sodium ion can be produced on a lithium ion production line. That's one of the advantages of it as a sort of next generation chemistry. You've not got stranded assets in terms of these gigafactories and all of the reel to reel coating and the ovens and so on that I mentioned before. It's much of a muchness. The chemistry is subtly different, but the way it's made is somewhat the same. However, in terms of being reproducible, so I should have clarified that's not so much to do with the chemistry and everything to do with the competence of the person who's making it. Because if you were really rubbish at making lithium-ion cells, you could have some that have a capacity of, say, 10 ampere hours, and then supposedly identical ones that are 8 ampere hours. And you could have like quite a high failure rate or rejection rate off the production line. And, the quality would just be completely naff. But no, what I mean by reproducible is being able to prove that they can make virtually identical cells. Because every cell is... every cell is going to be subtly different, but you want to minimize that difference to the point that it just doesn't matter. both in terms of capacity and lifespan and performance. But anyway, so obviously AMTI's proven that at the Thurso scale. They now need to prove it at the Dundee megafactory scale, and then they'll build a gigafactory somewhere, and then they'll be able to do it at that scale. So it's all about proving that they can cope with that ramp up in quantity, and bigger vats of material being mixed and so on. That's what I mean about reproducibility, minimizing that piece to piece variation.
Because people don't always realise how long it takes to ramp up production. So my background is in lean and continuous improvement. So people don't always realise that actually it takes longer than anybody would think to ramp up production, because of the fact that there are so many different factors involved. Supply chain, buying equipment, getting the right people involved, the numbers of people that you need, kind of forecasting the kind of the sales and things like that. It's something that I think, I'm not trying to go off on a tangent, but I think we people realised around kind of COVID when we were getting all the the vaccines were coming over, and actually people, why is it taking so long in certain places? But actually the manufacturing kind of uplift, it's not an easy thing to do, is it really? Increasing it so much, if you're talking times 2, times 3, times 4, there's all those extra things that are involved.
Spot on, absolutely. And it's it's one thing, as you mentioned, being able to produce something in a very small quantity, and it's the same with next generation cell chemistries as well. Plenty that I've kind of worked on, and my colleagues have worked on, where you'll start off making a cell that's about the size of it'll be a coin cell, so it's about the size of the cell that you'd find in like a car key, or some remote controls. And you only have one little disc of negative electrode of anode and one little disc of positive electrode cathode. But in the next step up, you would have multiple stacks. You'd have like well into the tens of stacks within the same cell, like in a pouch cell. So you prove that the chemistry works using something like a coin cell. And then you have to scale that to the point that you have multiple stacks in the same cell, whether it's a cylindrical cell or a pouch cell. And that, there are many chemistries that don't make that leap successfully. There's a very painful transition. And then once you've made them at a little scale and you've given them a fairly easy bit of cycling, where the C rate, which is the current over the capacity, in other words, how quickly are you charging or discharging it relative to its size. So it's a measurement that's basically an inverse of time. But once you've done kind of low C rate, gentle cycling of a coin cell, and you move up to like a pouch or a cylindrical, and then you push the C rates a bit higher as well. Oh, is the chemistry falling over because it can't keep up? And then you get to the automotive scale finally, and then you really beast it. So that's why these things take years to reach fruition, because we need to be very careful. Because there's some incredible chemistries out there that at coin cell level sound brilliant, but if I was to stick a whole bunch of them in an EV, they wouldn't last 10 charges. So you want to make sure that it's something that's actually fit for purpose.
The current gigafactory then, that's Britishvolt, how far? So if they did actually, and I don't know whether you're going to be able to answer this question, but if they did actually, if the UK government actually did say, right, yes, you can have this money, how far off kind of actually run off production do you think they'd be?
Allegedly 2025, maybe 2026. That would be that's allowing for an overrun. But 2025, with sufficient investment, like if the government and or the private sector was to come in and say, well, this is the biggest open goal ever, let's do this, because if you've got a few billion and you like money and you'd like to make even more billions, either for yourself or for a good charitable cause, then genuinely it's a no-brainer, because there is so much demand for electrification right now, not just in terms of transport, and it's not just cars. We're looking at vans, we're looking at buses, we're looking at boats, we're looking at trains, we're looking at the full shebang, and planes as well. Actually a short-haul flight, genuine thing, and like smaller jets and stuff. Genuinely, there's already electric planes in existence.
One of the courier companies like DHL, haven't haven't they got their first electric plane kind of it's been produced, or it's been there as a, I was going to say a pilot, but that's the wrong word, isn't it?
Hey. that's the perfect word. This is the perfect word. What a pun. It might be DHL. I do vaguely remember that. There is a logistics firm that's going down that route. EasyJet has stated that I think it's by 2040 they want to have like electric short haul flights, and actually aerospace is one of the sectors where electrification is making some of the biggest progress. Obviously not for like transatlantic flights or London to Sydney or anything like that, but there are lots of routes where, I mean, particularly in Britain, we are an island with lots of smaller islands off of us, and other kind of big places that are quite close to us. So you can imagine something like London to Amsterdam, or, even like the shortest chartered flight in the world, which, if I remember correctly, I know it's in Orkney, and I think it was Westray to Papa Westray or something like that, and it's 90 seconds.
What?
It's literally a puddle jumper.
God.
Yeah. You'd think that, if it was Denmark or Norway, they would have built a bridge, but Orkney, they went, yay, plane. So there's a tiny little plane that does this puddle jump, and they've just introduced a hybrid one, and I was virtually ripping my hair out at that point, because I was like, that's a the perfect opportunity for pure electric. You do not need an internal combustion engine anywhere near that. And one thing that Orkney has too much of is renewable energy. Yeah, they have so much wind power that they cannot use it all on site. And the grid connection to the mainland has maxed out. So, they've redlined that. They physically cannot export any more electricity. They've charged all their electric cars, because there's loads of electric cars on Orkney, by the way. A big shout out to Jonathan Porterfield of EcoCars, who single-handedly has imported the majority of those. He's a used car dealer who lives in Orkney. I've bought my two EVs off of him as well.
I'm going to write this down.
Yeah.
So
he's great.
Right, okay.
Jonathan Porterfield. But no, seriously, he just having that one evangelist on Orkney has resulted in Orkney being really big on electric vehicles. But anyway, they've ended up doing stuff with like converting excess wind power into hydrogen that they store, and then they kind of ship it from the wind turbines further north into Kirkwall Harbour and use that to power auxiliary services on ships that are docked at the port. But actually, the hydrogen storage is less efficient than if you were to charge a battery, or if you were to use it directly in some sort. Because it's like I think for every 3 electrons of renewable energy that go into that hydrogen storage system and then get run through a fuel cell, you only get 1 electron of renewable energy out, whereas for a battery it would be over 2. So, it gives you an idea. There's going to be losses for any kind of process, but there's a lot of processed in the hydrogen route, and there's a lot of different steps, I should say, and not all of those steps are terribly efficient. And there could be some room for improvement, but it's always going to be less efficient, unfortunately. But anyway, kind of going
There's
off.
always room for improvement.
Yeah,
That's me.
True.
That's my thinking. My other questions. What about sustainability when we're talking about batteries? How you hear so much about people kind of talking about the fact that electric vehicles aren't as sustainable as we think they are, or they may not be the right way forward, just because of the fact relating to the manufacturing process. And I don't know whether this is something that you can kind of answer, but what are your thoughts on that?
So there are obviously genuine concerns about sustainability, but genuinely, for every single aspect of sustainability where there's been a concern raised, or a naysayer shouting they are bad, fact, incidentally, if you write fact in full capitals at the end, you're probably talking nonsense. But the thing is that for every single one of these, genuinely, there is a company that has either commercialized a solution to it or is well on the way to commercializing a solution to it. And that's, I say a company, there's probably loads of companies. So how long have we got? Where can we begin? I suppose if we look at, I mentioned cobalt earlier, there's been a 90% reduction in cobalt which is an ethical concern because of Democratic Republic of Congo, which produces most of the world's cobalt. There's concerns about child labour there. So let's kind of roll back a bit and look at the big picture. So Democratic Republic of Congo, the vast majority of cobalt comes from big open cast mines that are run by big mining giants like Glencore. So there's very strict rules there about safety and about the age you have to be to work there and so on. So they're all properly looked after through like international standards. There are a small amount of mines that are artisanal mines, so that's individuals kind of digging deep holes and so on. And what's been interesting there is, okay, so that's a very, very small proportion of those artisanal mines you may find child labour, and that needs to be stamped out, and it is being stamped out. But artisanal mines make an interesting situation here because, well, for a start, DRC's reputation was kind of tarnished by that, so a lot of the big automotive manufacturers shied away from DRC. So you had this stampede of all the big players kind of running away from Democratic Republic of Congo, but then through the dust of that stampede came a little Dutch smartphone company called Fairphone. Now, Fairphone makes highly recyclable, highly modular, easily repairable, recycled and recyclable smartphones.
Right.
And they make sure that all of the materials that are used along the way, everybody gets paid a living wage, everyone has safe working conditions, that children are in school, not in mines. And they came running towards DRC and they were like, we want to help, we want to change things. And then shortly afterwards, the Fair Cobalt Alliance was founded. Fairphone is, of course, a member, as is LG Chem, as is Tesla. There are numerous big, battery and electric vehicle makers who are part of this, and they are making sure that these lives in DRC are being changed for the better. So children are in school, wages are fair, so the working conditions are safe. So that's just cobalt. But it's also worth pointing out that there's a cobalt-free version of lithium ion called lithium iron phosphate, which, if you think about it, is basically made from rust. It's incredibly cheap, incredibly ethical, incredibly long-lasting. It's safer.
Okay.
It's got a whole bunch of advantages. The issue was it didn't have as much energy density, in other words, as much range per charge for a physical size of battery as your kind of cobalt-containing chemistries. But there have been recent improvements in energy density that have allowed Tesla to get over 200 miles per charge out of their standard range Model 3, which contains an LFP battery. MG has adopted it on the standard range MG4. Maxus has adopted it on the standard range Deliver E9 or eDeliver 9, I think it is. Sorry, Maxus. But anyway, point is that they're starting to become widespread in electric cars and vans, and they've been used in electric buses for the best part of a decade because buses have loads of room for batteries. So they didn't need to worry so much about the energy density. So actually, if you look at the fact that there's no cobalt in there, and you look at someone driving a V8 Range Rover who pulls up to someone who's plugging in their car and goes, "Oh, those are bad because of cobalt," actually, one of the main uses of cobalt in the catalyst industry is in the refining of petrol and diesel. So every single petrol and diesel and hybrid car out there uses cobalt, and in fact it uses more cobalt than a standard range Tesla Model 3 or a standard range MG4. And if that person was to then go on to Twitter and tweet about how bad electric cars are because of cobalt, their smartphone contains more cobalt than those electric cars. Yeah, that's way more cobalt than a standard range Model 3.
Goodness me. Okay. This is just absolutely fascinating. I do have loads more questions for you. I think
Go for it.
Well, I was going to say I'll talk to you for another few minutes, but actually I'd like to get you back on again if you're up for coming on again.
There's going to have to be a part two, isn't there? This always happens.
To be a part two.
Yeah,
what about
okay.
so size and cost reduction of the battery? So what does if we're looking at, you just mentioned an MG4. I'm actually going for a test drive in an MG4 for the very, very, very first time tomorrow. So I've never ever driven an electric vehicle.
What? Oh my goodness! Well, you're going to be blown away.
And actually, bizarrely enough, well, no, it's not bizarrely enough at all. I felt that I can't be doing this podcast and not be experiencing this. I mean, and there's about 3 or 4 vehicles that I've been keeping an eye on, and the MG4 is one of them, and the Cupra Born is another one. So I'm actually test driving an MG4 tomorrow, and I'm test driving a Cupra Born on Saturday. which I'm really, really looking forward to. But if we look at so for an MG4, for example, how big would the battery be? Because I know they're on the underside of the vehicle, aren't they? So
yeah.
How much space do those? Because you've kind of explained about how many you actually need in succession. How big?
Yeah.
What surface area are they taking up?
So particularly with the lithium iron phosphate ones, they're going to be, kind of elbows out, taking as much space as they can. Because yes, there's been improvements in energy density, but they still need to be able to fit enough in to get the sort of ranges that consumers would expect. The MG4 can do, I think it's about 200 miles per charge on its LFP lithium iron phosphate version, and then 300 miles on the NMC, the cobalt containing version. But I say cobalt containing, it's not a huge amount of cobalt, it's mostly nickel. Anyway, point is that the space that it takes within the car, an electric vehicle that's been designed from the ground up will have what's called a skateboard platform. So you've got your four wheels, and then you've got a flat, skinny battery pack that takes up most of the space between those, excluding where the motor is, either at the front or the back or the both. So yeah, they're generally going to be very flat underneath the bulk of the car, but they'll also be surrounded by an incredibly sturdy crash protection structure. There are some electric vehicles where they don't follow the skateboard platform, the likes of the Nissan Leaf. It's almost like you took the skateboard and kind of folded it in half, so it's kind of double thickness, but half
like
the length of the car, if that makes sense.
Yeah,
exactly. Yeah, exactly. And it's a slightly funny shape, and there's like some of the modules, so basically the building blocks that contain the cells. Some of them are kind of like orientated this way, some are this way, which is quite weird. I don't know why Nissan did it that way. But yeah, mostly you'll find that the cells are all kind of neatly aligned in the same direction, and there's not too much thickness to it. The Mini is an interesting one, because if I remember correctly, the Mini has a bit of a sort of T-shaped battery pack. There's no need for a transmission tunnel in that Mini, but they've kind of put it where a transmission tunnel would have been, which is quite strange. So as I say, you've got this kind of weird T-shaped pack, which would normally mean, you've just increased the center of gravity versus a skateboard, which means it won't handle as well. But although I've yet to test drive the Mini, I'm reliably informed it is an absolute hoot of a car to drive.
Yes,
so
I've spoken to Ben Travis, who is a Mini EV enthusiast, and he raves about his Mini EV. So yeah, definitely. He's actually said that I must test drive an electric Mini as well. So yeah, that's on my list. Ben, if you're watching.
Whilst you're at it as well, purely just for the fun factor, take out a Honda E. So the Honda E's range is not great. It's about 100 miles per charge, which is #so2015. And this is the thing about, so Japanese electric cars are under-specced and overpriced because Japan went big on hydrogen and has only recently just kind of admitted it to itself, with the notable exception of Nissan, which is partially owned by Renault, which went big on electric vehicles. And then it was Carlos Ghosn, the previous CEO of Nissan, went big on electric as well, and that's why we've got the Nissan Leaf, which has some flaws but is mechanically borderline indestructible and all of this. So anyway, yeah, kind of going down a rabbit hole again. But the Honda E is basically a city car. But it could do cross-country journeys if you want. The rapid charging is not particularly fast. The range isn't particularly long, but it's such a head-turner. That styling, there's nothing else like it out there. The interior is kind of very retro. It's got a very flat, like you could actually sit a coffee cup on it, kind of wood veneer dashboard with screens all the way along, and there's even like a virtual aquarium where you can feed the fish and things like this. And unusually for a car of its size, it has vehicle to load, so it's actually got a power socket, UK power socket on the dashboard, and it's also got an HDMI port, so you can plug in a games console when you're parked up, and you can play Mario Kart on the screen on the thing.
My son would love that. Anything to do with gaming, he'd love it.
Well, there you go. It's just, I've never seen any other car like that. Also, it turns on a sixpence. It seriously gives a London taxi a run for its money, because it's designed for urban environments. Incidentally, shameless plug here, it was one of the cars that we reviewed for one of my other projects. So there's Plug Life Television, which is my channel, but there was another project, the Faster project, which is installing 73 rapid chargers across Republic of Ireland, Northern Ireland, and the rural west of Scotland, basically filling gaps in the network. It's an EU-funded project, and And for part of that project, they've done a public outreach thing. So there's been some very serious webinars covering, what needs to be done to improve electrification. But there's also been a series of electric vehicle reviews. So basically, me pretending I'm on Top Gear, along with Rick Bullemere from Generate Media and his team who filmed it. They've just been absolutely brilliant. The first episode was the Honda E, and yeah, genuinely worth the watch, but just because the E, if you've never seen it before, is just so different. Thank you, Honda, for doing something interesting in a world of cars that have kind of converged on the same kind of blob design. This is just, it's got personality. I love it.
That's why it's taken me a while to actually come up with just a few that I'd like to test drive in the first place, because at the moment, and I know I'm not the only one, so people who were watching this will probably also be in the same situation, that I have no frame of reference when it comes to EVs at the moment. I want to have a frame of reference, so I'm not going, much to their disappointment tomorrow, I'm not going to buy or lease an MG4. Yeah, I want to actually try a few different EVs before, kiss a few EVs before I meet my Prince EV.
Yeah.
You know what I mean?
Fair point. And actually, do you know what? A really good thing that might be of use to some of your viewers and listeners who are in the same situation as yourself. You don't. It's that whole kind of high pressure environment when you go into a dealer and they can kind of, it's like a shark. They smell blood in the water and they go straight after you. But where we did the filming for the Faster project in Glasgow was the Arnold Clark Innovation Centre. So although it's Arnold Clark, which of course is dealers, they've got this centre that's purely there to educate people in electric vehicles. They have just about every EV on the market, and you can test drive as many as you want, and they've got very friendly, knowledgeable people who will tell you all about them, and you're under no pressure to buy. It's purely there to educate. There's one that's opened up, I think it's in Stafford or Staffordshire. So there's one that's more kind of central England, that's just opened up. So yeah, between Glasgow and Stafford, there's hopefully one not too far away from you that you can go and check out, because it's like you'll get probably the MG4, the Mini, the Honda E, any kind of other EVs out there. You'd have them in the same place. You could go through them all in one day if you want.
I suppose that's what I was looking for. So I interviewed John Burdekin a few weeks ago, and he was talking about there was a similar kind of innovation centre that was up in Milton Keynes, which Milton Keynes is only like an hour away from me. So, but I looked into it and that closed down a little while ago. So, which is a shame.
It's interesting you mentioned that, because that was BP Pulse that ran that.
Yes, you're right.
And BP Pulse, notorious. Actually, so Milton Keynes is BP Pulse's capital city, if you wish. It's where their headquarters is. And yet, obviously, they've got a lot of charge points there, and I can tell you from personal experience that you can sometimes struggle to get one that works. So you think that they would fix that, but BP Pulse has announced recently, to their credit, that they've invested are going to invest about £1 billion in improving the network. So we should see significant, hopefully, improvements shortly. But shortly after announcing that, they shut the BP Pulse Experience Centre. It's like, that's a bit of a mixed signal, isn't it? But yeah, I mean, on the plus side, though, having said that, the number of charging networks that are springing up now that are doing really high quality charging hubs is very heartening to see. There's some very big players who are about to throw their hat in the ring, and then there's some that have just kind of quietly come from out of nowhere. So like Motor Fuel Group, MFG, they have franchise petrol stations, and they didn't kind of make a song or dance about it. They just started building really big charging hubs, and everyone loves them. I think they're kind of towards the top of the ZapMap user surveys of favourite networks.
And it makes sense.
Now, so,
It makes sense. A lot of these, like I say, I've kind of said to other people, the innovation in the industry is really, it's really good. So actually, it's kind of interesting to see the joined up thinking for all of this, because it makes sense, doesn't it? When it comes down to it, it makes sense for them to do that. So in the next kind of 7 years, I'd love to see, fly on the wall 7 years time. What's all this going to look like? It'll be really, really interesting. But what I was going to say was, just to finish off, because I do want you back on again, please. Yes, please join me again.
Yeah, let's do this.
And in fact, I'm gutted that I didn't get to Oxford, which is only ridiculously close to me, but working. So, we could have met there. But right. So your YouTube channel is Plug Life.
Yeah, Plug Life Television.
Plug Life Television.
Yeah.
You're on LinkedIn.
I am indeed.
Where else can everybody find you then?
So you'll find me on Twitter at 106ewan, and as well as the Plug Life television website, I've mentioned as well, there's the YouTube channel for the Faster project, where you'll see basically kind of 50-50 split of highly informative webinars with key stakeholders from Scotland, Northern Ireland and Republic of Ireland, talking about the state of the charging infrastructure there, talking about electric vehicles for fleets, used EV buying advice, new EV buying advice. The next webinar is going to be on accessibility and inclusivity, because what if you have mobility issues? What if you use a wheelchair, for example? What if you are a lone woman driving at night and the only charger's in a dingy kind of corner of a badly lit car park, things like that. So there's going to be some really interesting panelists on from Motability, from Charge Safe, Kate Tyrrell. There'll be some very important stakeholders there talking about what can be done and what is being done, along with some examples of best practice there. So yeah, we're covering all sorts with that, but the other 50% are the EV reviews. The latest one is the Hyundai Ioniq 5 and the Kia EV6, two basically identical cars underneath, but very different on top. Which is best? We took them on a drive to Whiteley Wind Farm, biggest wind farm in the UK, and had a car-powered picnic.
Oh, I love it. Do you know what? That is another one on my list, the Ioniq 5.
It's a good one.
So I'd like, so like I say, there's not many on my list because I really don't want, I'm not looking for a big SUV. There's only 3 of us in our family. And like I say, you know, and obviously there's a very, very, the price difference for an EV is very much higher, you know, than kind of like an internal combustion engine. But yeah, so it's a start. But listen, Ewan, this has been an absolutely fascinating conversation. I really, really appreciate your time. Like I said, I've got to have you back on again because there's so much, and also, you know, I was kind of thinking, mate, what I might do is I might bring some of my previous interviewees into the room together, because depends how many people can fit on this screen.
True.
Not that if anybody's listening, I'm sorry, it's got the size of a Zoom screen, this one, but I don't know how many people I can actually fit on it. But I think maybe I need to do that and just get some more conversations going. But Ewan, thank you.
Good to
thank you very much. It's really, really appreciated. So I'm going to say goodbye to everybody for this time. I'll see you all later. And again, thank you very much, Ewan. Bye everyone. Bye. You've been watching Electric Evolution with Liz Allen. Don't forget to subscribe and click on the bell icon, and you'll receive all of our weekly videos. Thanks for watching. See you soon.